Welcome to my video tutorials. This time we will talk about single-phase AC electrical circuits. AC means alternating current. Previous videos were about DC, direct current, and now we are going to talk about alternating current. First of all, let's understand what does alternating current mean. The best way and the fastest way to understand what alternating signal mean will be the following graphic. We have two axes of signal amplitude value A from t and axis time t. Means amplitude of a signal depends on time. For example, we have sine form of a signal. Such signals have the following parameters: period of signal t, a half period t divided by 2, and maximum value of a signal am, m maximum. Respectively, we can write the following equation. A, which depends on t, is am sine from wt plus phi, in which we know all variables: am, signal amplitude, t is the time during which the signal amplitude changes, and phi, phase. In our case, it's 0. And let's talk about wt. When t is a period, wt will be 2p, and w, circular frequency, will be 2p divided by t, which is 2pf, where f is a frequency, measures in hertz, 1 divided by second. F, it's the same as 1 divided by t period. So we understood the principle, and when we start talking about voltage and current, will be the same situation. We have the graphic on which will be presented the dependence of voltage of time. Voltage and current both have sine form of the signal. Respectively, their equations will be looked like in the previous explanation. Comparing to DC circuits, this time we will have additional elements, and first element will be inductor. Common presentations in SCAM will be the following two variants. First and second one. Electromotive force of self-induction will be described by the following equation, and the voltage drop on inductor will be minus EL from T. So, as you can see, the voltage value depends on time, and will be described by the following equation. WL is a inductor resistance, and IM and UM is an amplitude value of current and voltage respectively. And what we can conclude looking on the last two equations. The voltage in circle with inductor goes faster than current on P divided by 2. When we are talking about capacitance and circuits which include capacitance, the current will be the function of time and will be described by the following equation. In this equation, 1 divided by Wc is a capacitive resistance Xc. Comparing to circuit with active resistance, the current was described by the Ohm's law. In the circuits with capacitors, will be the same Ohm's law equation, just with capacitive resistance Xc. And capacitive resistance Xc is 1 divided by circular frequency W times capacitance C. And the last equation gives us the following result. Current in the circuit with capacitor goes faster than voltage on P divided by 2. And let's take a look on the following two examples. First example describes the circuit, which includes inductor. Current in this case have the same equation and the same shape. Let's remember the equation in circuit which includes inductor. In sine argument we see plus p divided by 2. What does it mean? Let's build a respective graphic. Thus, we confirmed the previous result. Voltage gets its maximum value faster than current in circuit with inductor. Another example according to scheme with inductor. Maximum value of current is 1 A and maximum value of voltage is 40 volts. Voltage gets its maximum value in 0 seconds, but current gets its maximum value, in P divided by 2 seconds. You can very easily convert P divided by 2 radians in seconds. The main idea to understand it, voltage goes faster than current and gets its maximum value. On vector diagram, we will have the following situation. Okay, now I hope you understood it very well. Next, we need to describe the situation with circuit with capacitance. Let's remind equations for voltage and current in circuit with capacitance. And let's plot respective graphs. Voltage has phase phi0 and current has phase plus P divided by 2. It means voltage gets its maximum value P divided by 2 later than current. Or in other words, current in circuit with capacitance goes faster than voltage. And how it will be looked on a vector diagram. Thank you for watching.